calculus lesson on separable differential equation, guys. Okay. All right. Have your notes ready, and let's get started. Okay. I already sort of pre-filled out some of the stuff over here. The separable differential equation is a first-order differential equation in which the expression dy dx can be factored as a product of function of x and function of y. What that literally means is that you can write dy dx is equal to g of x times h of y. Sometimes it's hidden. It could be written as g of x over h of y, but as we all know, the quotient is a form of product, right? We could separate them, this right here, as a 1 over h of y. Okie doke. Ultimately, the goal is to actually separate them. Let's say we move the dx on this side. What we could do is put all the x's on one side and all the y's on the other, and we could probably integrate both sides and solve for it, right? And we could do the same thing. In this particular case, dy dx is equal to this. Let's put all the y's on the left-hand side and the x's on the other. And we could integrate these. And that's what we're trying to do, guys. Okay? You'll see more in a second. So if that's the case, right? Which of the following are separable differential equations? If you said A, B, and C, you are correct. Okay? So for A, ultimately we could write that as what? I mean, it is written as we can write it as a product, right? So the answer is yes. Okay? How about this? Dy dx is x over x squared minus 9 times y, right? So the answer is yes. Let's get D. So that is dy dx is equal to 1 over x times e to the dy plus 1. So the answer is yes, because this is a function of x and that's a function of y. This is function of x, function of y, and function of x and function of y. Now let us look at C. Looks like the best we could do is factor out the y, and we get xy minus 2x squared. Notice that there's no way for us to tease the x's and y's apart, but this is not separable. Okay, guys? All right. So let's reiterate what I essentially said earlier here. I went kind of fast, so here is a step-by-step. The basic steps to find the solution of separable differential equation is that we need to manipulate algebraically so that the format is dy dx is f of x times g of y, I'm sorry. All right. I apologize for just going back and forth with different notations. Okay. And then we're going to move all of the y's to the side of the dy and move all the x's to the side of the dx. And that's essentially what I did over here. See that? I pull out the dx to this side, put the h of y to this side, and that's what we do, right? And then we're going to integrate both sides. Don't forget, because it's going to be indefinite integral, you're going to have to introduce c. And then you're going to have to solve for y if possible, right? There's a good chance that it won't be possible, but if it is, you should. And then plug in any value from initial condition to find a particular solution, if that is an option. Okay? All right. It's a reminder, note, that be sure to combine all the constant into a single constant, guys. You don't want to have C1 on the one side and C2 on the other. Let's say x and a y, plus plus. You want to move that to this side, or something like that to combine all the C values. All right? Okay. All right, guys. Let's do some exercises, all right? Some examples to see what I mean by that. Let's look at the first one. Ooh, looks like we do have initial condition. Okay, let's zoom in this one. What we could do here is to put all the dy's on the one side, all the dx on the other. Like this, right? Yes. And then we're going to integrate both sides like this. Now, this one is a y to the negative 2. The antiderivative is you add 1 to the exponent and divide by the resulting value. As it turns out, that would be antiderivative of that is y to the negative 1 divided by negative 1, right? Right. So that is equal to 1 over y plus c1. The next one is what? Oh, you know what? It actually might be... It looks like I forgot the negative sign over here. Okay. And the next one's going to be negative 2x squared plus c2. I got the two negatives, so they make it positive, right? And the fact that I have two c1s, let's put one to the other side. Yeah? Which would make it 1 over y is equal to 2x squared plus c. So I'm going to have to solve for y by flipping it, right? So this becomes 1 over 2x squared plus c. So we are done with that portion, but it says what? Y is not equal to 1. So plugging the x equal to 0, and the y value then is equal to 1, we could clearly see that from here the c is equal to 1, right? Therefore, my particular solution is y is equal to 1 over 2x squared plus 1. Alright guys? There you go. Alright guys, let's just continue. We have the second example here. What to do, what to do? Okay. So we know that the y prime, this is what? dy dx, right? So when you solve for that, dy dx, it should be equal to e to the 2y sine of x over cosine squared of x, right? And I'm going to put all the dx's on the one side. I'm going to move that to the other side like this, right? When you do, you end up with e to the 2y dy is equal to, okay, that's, we could separate them, right? So this right here is sine of x of cosine of x times 1 over cosine of x, right? So that's tangent and secant, right? So that will be tangent x, secant x, and dx. We're going to integrate both sides. And on the left hand side, it's going to be 1/2 e to the 2y plus the antiderivative of that is a secant x plus big C. Because I know that it's going to be C1 and C2, I'm going to move it over. So I don't even bother with it anymore. I just put it on one side. Okay. Now we do want to solve for y. So let's do this. Let's multiply by 2 to both sides. Remember, twice the constant is still a constant, right? Right. I'm going to ln both sides. When you do that, let's just write in green for a second. Like this. Alright. So when you do this, what do I get? Ln of 2 secant x plus c. On the left hand side is this right here, isn't it? Right. So if you divide both sides by 2, you get 1/2. Now, you could go ahead and try to simplify this. If you leave it alone here, perfectly fine. Or, you do realize whatever is in the front over there could be written as an exponent right there, right? Which means that that is ln of the square root of 2 secant of x plus c. Because there is no initial condition, we just leave c as it is. The reason why it's important for you to understand this is that if you get this question in a multiple choice, you have to recognize that they're both valid. You don't know if the question maker, in a multiple choice question, will give you answer in this format or this format. So it's important for you to know how to manipulate the expressions in different ways. All right, we got one more, guys. So this is separable. Okay, so we got dx over here. We got a function of x, and we got a function of y. Ooh, they're both in the denominator, aren't they? All right. So we got 1 over y to the third dy is 1 over 2x plus 1 dx. We're going to integrate both sides. Yeah? All right. So from our experience, we know that this y to the negative 3. So antiderivative of that will yield 1 over negative 2y squared. And this right here is, if you take that as a u, you know the half will pop out, right? Right, so for those of you who are not very comfortable with this, you should do a u substitution. Why don't I do that, okay? So the u substitution is this, 2x plus 1. That means that du is equal to what? X dx. So 1/2 du is dx, okay? So let me put that right there. So what that means is that this is 1 over u and dx is 1/2 du. So the antiderivative is what? Ln of absolute value of u, right? But what we're going to do with that, du, is we're going to plug it back in, which is 2x plus 1. So that's what happened, okay? All right, guys, we're going to put plus c on the right-hand side because there are plus c here, plus c here. I'm just going to move it and combine it to 1, all right? All right, we need to solve for the y over here. So what do? Yeah, halves cancel. There's a negative sign over here. Let's move that along, right? And then what we end up with is y squared is equal to negative 1 over ln of absolute value 2x plus 1 plus c over here. Yeah. So the y is actually plus or minus, right? The square root of 1 over negative 1 ln of absolute value x plus 1 plus c. And we're not quite done, guys. We have an initial condition. Y of 0 is equal to negative 2. That's the x coordinate. That's the y coordinate, right? So what that means is that negative 2 is equal to plus some, oopsie, sorry, hold on. It's equal to plus or minus the square root, but because it's negative, this cannot be positive, right? Right. And then that is negative 1 over ln of 2 times 0 plus 1, which is just ln of 1 plus c, right? But we all know that this is equal to what? 0? Right. Okay, so now what that means is what? It's negative and negative, so we could get rid of negatives now, right? It's equal to square root of negative 1 over c. We could square both sides. What is c equal to then? Negative 1/4, isn't it? Right. Therefore, y is equal to plus or minus square root of negative 1 over ln of 2x plus 1 minus 1/4. It actually might look better if you just put to the power of half. Sounds good? Alright guys, that is it. In your notes, you have 2 problems here, guys. Okay. they're kind of similar. So why don't you try this on your own? And I'd like to see how much of this you're able to do. All right, guys, that is it. Okay. All right, guys. I'll see you in the class next time. Okay. Have a good night.